I'm going to go ahead and get started a few minutes early so that Charles can start right on time at 2 o'clock because we're going to be doing some speed dating every 20 minutes. So you're going to have a new date. So my name's Frank Berry. I'm the Vice President of Marketing at MemVerge, and we manage this industry initiative called the Memory Fabric Forum. And it's a series of events, websites, YouTube channel. It's all about memory fabric technology. Participating is free, and the aim of it is just to accelerate collaboration on the marketing side, on the project side, on the technology development side. And this is our 12th Memory Fabric Forum event. This is our third time we've hosted this event at the OCP Summit. And at the end of this year, we're going to start a new branch of this initiative, which we call AI Infra Forum. So presenting at these forums is free. So if you're a thought leader, an individual thought leader, or if you're a vendor out here that would like to do a presentation at one of these events, my email is up there. Just contact me and we'll get you involved. So with that, I'd like to introduce our agenda. We've got 12 presentations during the next 5 hours or next 4 hours, ending at 5 o'clock. And our first speaker is Charles Fand. He's the CEO and co-founder of MemVerge.
All right, good afternoon. I guess I'll be the appetizer for the event. It's our pleasure to host. This is really for the ecosystem partners to come together, share information with each other, and to see how we can accelerate the advancement of technology in the area of memory fabric, especially as AI is becoming increasingly important in driving the transformation of the data center architecture. So what's the transformation? Here is a simplistic view of it. We were in the x86 era for the last 40 years, and there are three pillars to a data center: compute, networking, and storage. Where the compute is centered around x86 processors and the DDR, DRAM, and networking is typically connected by a TCP/IP network, and storage attached to that particular networking fabric. And these three pillars really formed the data center that we got used to in the last 40 years. And in the last 10 years, we are seeing the starting of the transition into AI infrastructure. These x86 TCP/IP network storage continue to exist, but there emerge a new computing core that's centered around GPUs and other AI processors. And there are high bandwidth memory very close to these new processors, providing very high bandwidth, low latency access by these processors. And there emerge, we believe, a new AI fabric. And that's really the central topic of the session, that there is a number of protocols, standards, and proprietary technologies that has emerged that interconnect these AI processors together between computing units as well as between computing units and memory units. These including NVLink, InfiniBand, CXL, UA-Link, Ultra Ethernet, etc. And we are going to dive into each of them by our partners. And that's probably going to be the main thread of this Memory Fabric Forum. And we believe there will also be a new data leg that's attaching to this new fabric that is going to be memory-centric. That's going to be a new data platform where data can be stored and shared and transported between the computing units. And combining these three things together is going to be the new AI computer, the new processor, new fabric, and new storage. And so now let me just give you a quick overview of each of these new fabric, much of which you're probably already familiar with. NVLink is really the leader in the space, and this is a proprietary NVLink NVIDIA technology that is very high bandwidth that interconnects between the different processors. It started as a intranode technology where you can connect up to 8 GPUs with each other in a full mesh to providing very high bandwidth, 900 gigabytes per second between each GPUs. With the new Blackwell technology, this became a rack scale technology. So as you see here with NVL72, you can connect a SuperPod with 36 ARM processors plus 72 Blackwell and providing an aggregate bandwidth of 130 terabytes per second. That's amazing amount of bandwidth that interconnects this really a supercomputer in the rack. And now this is, I think, on the leading edge today in terms of the AI fabric interconnecting the different processors. And then there is a kind of backend network that goes beyond the rack scale that can connect to thousands of nodes to allow these large-scale distributed training and other activities to happen. And InfiniBand is a leading technology today as this backend fabric that's connecting a larger scale of computing nodes together. And this is a very fast-growing market. NVIDIA, again, is leading the way with the acquisition of Mellanox, is a leading supplier of the InfiniBand technology. And it is predicted to double to almost $80 billion in the next 5 years. And the bandwidth will continue to increase as well. Now, to compete with InfiniBand, we are also seeing the high growth of the Ethernet-based technologies, in particular, Ultra Ethernet. And there has been a formation of an Ultra Ethernet consortium, and the bandwidth is increasing pretty rapidly from 800 gigabits per second, now with 1.6 terabits per second of Ultra Ethernet connections. And we are also seeing in the recent months of the formation of a new standard called UA-Link. And this is a collaboration with a large number of industry leaders, trying to creating a more open system alternative to the NVLink to allow the non-NVIDIA world to have a high bandwidth, multi-pathing way of the processors to talk to each other. So there are some very exciting emerging development, and I think we will have session to go into each of these. And last but not least is CXL, and we have been working on CXL for a while. This is a new memory fabric that's built on top of PCIe Gen 5, Gen 6, and this allows the memory to be disaggregated, to be composable, and to be shareable between the different processing units. And slowly but surely, there has been steady advancement of the CXL technology, as well as the productization of such technologies. We are starting to see the initial memory expansion devices based on the CXL protocol. And we are also starting to see, as you will hear from the presenters, a new CXL switch becoming available that allows multiple servers to be interconnected on the same CXL fabric and have access to the same memory pool. And this opened up for some exciting possibilities for the data to be shared, not only in the AI fabric space, but potentially in a fabric-attached memory space to have a new data platform. So this is a list of various new fabric hardware that are growing very fast. And over the next 5 years, it's going to be very exciting to see how this market evolve and which ones will be the standards. And as I will introduce towards the end of this presentation, I think there could be more than one winners in this space. There could be a coexistence of multiple fabrics to serve different purposes. Okay, so those are the kind of overview of the hardware technologies. Let me go into the software a little bit. And MemVerge, the company I work for, is a software company developing software on top of AI fabric and on top of memory. And I'm going to give you a couple examples on the software that we're working for that runs on top of these fabric that can provide interesting capabilities to the AI applications as well as other applications. The first is CXL-based memory sharing. And this is a technology we have been developing for more than 2 years. It came in the form of a project we call Gizmo. It's a global I/O-free shared memory. It's come in the form of a memory appliance where we run the software on top of this appliance. It allows multiple servers, as you see on the right-hand side, and which could have multiple worker processes, accessing a shared memory through a object interface. And these are memory mapped objects, so that it can be accessed. The data path can be accessed with memory semantic to allow very high bandwidth and low latency. And these physical nodes can be connected through that CXL fabric to the same memory pool. So this basically allows the same region of memory to be read and to be written to from multiple processes on different nodes. So conceptually, what we can do with shared memory on a single node today can now be extended through this memory fabric to multiple nodes to allow some very exciting new application possibilities. And one of which is we have integrated various layers on top of Gizmo, including a Luxio caching layer, as well as Spark, which we can run on top of it. And then we ran a number of benchmarks, TPC-DS, which is a analytical database benchmark. And we can demonstrate higher performance from those benchmarks compared to the classical networking approach. So in this way, this is really a replacement of I/O. Instead of using networking to do the data exchange or reduce between the different computing nodes, now we can use the shared memory to accomplish the same by multiple nodes accessing the same memory region. So that's first example of a interesting application on top of a memory fabric connecting to a common memory pool. We are also working on composable memory expansion, meaning on top of the same memory fabric, you could have a pool of memory available that dynamically extends the memory capacity of different computing nodes. And today, it's primarily to the CPU memory, but it can be extended to extending the GPU memory as well. And we developed different policies where we can manage such memory expansion by applying different tiering policies. It could be optimizing for the latency of the access, and it could be also be optimizing for the bandwidth, either to minimize latency or to maximize bandwidth to allow the overall best system performance from this cluster. And here is an example of running the memory expansion software on top of a CXL memory modules, where we run Weaviate, which is one of the vector databases that are popular in the RAG implementation in an AI system, where we can demonstrate by adding a 20%, or 10% or 20% memory, we can increase performance by 7 or 8%. So this just purely by extending the bandwidth the memory system can provide, we can proportionally increase the performance of a vector database applications on top of it. So here are just a couple of interesting software examples. There are many others that could be possible as well, and we are actively working on those. Okay, now let me complete my presentation by providing a few predictions, and 3 predictions, really looking at the next 5 years. A few observations, really, what I think is going to happen based on the interactions we've been having with customers as well as with our partners. And some of them may be obvious to everyone, some of them may be controversial. So the first one is that as we talk to more and more customers, that we have observed that GPU is certainly still a very valuable, expensive, and scarce resource that people are trying to get. And they tend to be, their availability tends to be unpredictable on the public cloud, and it's quite expensive on the cloud as well. So many of the larger enterprises over the last 10 years have, cloud initiative, try to move as much workload to the cloud as possible. Now we are seeing a little kind of hybridation to that strategy, in particular when to relate to GPUs. We are seeing there are projects that enterprises are revamping their data centers so that it is ready with the power and cooling for GPUs, and they start to build on-prem GPU clusters to balance out their presence in the public cloud space. And even in the public cloud space, it's certainly, aside from the hyperscalers that we are all familiar with, there's a new breed of GPU cloud providers that are specific to the GPUs. So we are foreseeing really in the next 5 years, it's going to be a hybrid world where the enterprises are building their own GPU clusters as their strategic assets. The GPU cloud service providers are going to continue to grow, and hyperscalers continue going to be big players. And it's going to be a mixture of these GPU resources. So the management of these hybrid resources, I think, can be an interesting problem that the ecosystem should provide solutions for, and how the workload can intelligently select the right computing resources to go to for whether it's training, whether fine-tuning, whether it's inferences, finding the right resources to complete. All right, so that's number one. So number two, as I mentioned, we believe AI fabric is going to be a very active space where there are going to be a lot of smart people inventing new technologies, pushing the envelope, and we believe that certainly NVLink will continue to be an important player in the space. NVIDIA is going to continue to be a dominant force in the space, but there will be additional industry standard AI fabrics that will emerge and adopted, and it's going to be a more complex world in terms of this interconnection between the processors. So it'll be interesting to see which protocol will win out and which will fade away, and then there are new software and application technologies built on top of the emerging standards. And the third prediction is more closer to what we are focusing on at MemVerge, that we do predict that there will be a new technology that's fabric-attached memory. And in particular, for the AI applications, this could be a very useful new layer in the infrastructure. It's going to form the lowest tier in the memory hierarchy, from the SRAM cache to high bandwidth memory to the main CPU memory, and then to this fabric-attached memory. That all of them can be accessed through memory semantics, and it can be dynamically resized or reattached to improve the overall performance of an AI application. And this could become a internode shared memory for things like KV cache that can be shared. And this could be playing an interesting role to handle the fault tolerance of various computing units in the whole cluster as well. And this could also serve to replace some of the performance tier of storage today, where the data loading will happen with much faster speed, and where the checkpointing, which is a very important task as part of the AI, can be further accelerated, and where storage became to serve more of a capacity needs, where the performance-driven I/O can be handled in a memory-centric manner. So we do think there will emerge a new data layer that's a fabric-attached memory. Okay, so that's the end of my section. I hope I'm not over my time. Yeah, any questions? Yes. Yeah, the microphone there.
Yeah, you touched on, in one of the slides, you touched on
Which?
The last tier of memory, where, the fabric, sorry, that was my question. The fabric slide, where you have multiple fabrics emerging. Now, these fabrics, do you think any of these are trying to merge GPU and CPU memory? Because a server normally pays heavily for both of them. And what is churning in industry in terms of any undercurrents to merge these memory or make these two big entities share memory?
Yes. So, so today, CPU memory and GPU memory are difficult to share in general. Now, there are some interesting development. NVIDIA has developed the Grace Hopper and Grace Blackwell architecture, where there is a chip-to-chip NVLink between the CPU and GPUs, and then they create a cache-coherent access between the GPU and memory and CPU memory. So you could have 96 gig of GPU memory with 480 gig of Grace CPU memory, and they can access each other in a cache-coherent way. But that does require a new Grace Hopper architecture. For general x86 attached GPUs like a DGX system, it is difficult to share the memory in a transparent way. So this is typically done at a higher level, say if you're using VLLM or using other PyTorch that you need to kind of more explicitly doing what's called memory offloading in terms of what's, let's say if the memory doesn't fit into the GPU anymore, there are typically two ways. One is adding more GPUs, so it kind of scale out, which has its own challenges. The other is memory offloading, where you move the unnecessary KV cache and so on, necessary but less used, move them to the CPU memory to relieve the memory capacity bottleneck. So there are various techniques being used, but nothing is perfect right now. And I do believe there's an area between hardware and software we could innovate to create a more scalable, continuous memory tier that can enable better processing of the AI workload. Yeah.
One more follow-up question. You touched on UA Link. I'd like to request your opinion or comment on how UA Link is transpiring in terms of initially the first version apparently is to network only GPUs. Do you feel that there is a need to allow more other disparate accelerators to come and network over UL? Thank you.
Yeah. So do we have a session on UA Link? Yeah, so for sure, I think there will be a session focusing on UA Link, which can probably provide more authoritative answers to this question. My belief is it is within the scope of the objective for UA Link. Yes.
Do you think co-packaged optics will have any effect in the future of memory fabrics?
Yes, I definitely believe so. I think there are some exciting startups working on those technologies, and that's going to provide really lower latency and higher bandwidth, and I believe that's going to really enable this vision of where you can have a pool of memory that's at the fingertip of all the processors there. So it's definitely going to be enabling technology.
And what time frame are you expecting that?
I hope ASAP, but from what I know, I think it's more like 3 years, 2 3 years. Yeah. Okay, thank you very much.
Thanks, Charles.